Okay, yeah, let's just switch to code. Ah, I have some viewers. Okay, that's cool. So, hold on, some stuff to just move around. Okay, I don't have a fancy microphone today, so we're going to just put up with potentially worse audio quality. But anyway, I don't think I'm going to stream for very long. I just want to do some stuff and not like stop the streams completely because I haven't streamed for a while. Happy Christmas, by the way, everyone. A bit late, but you know, I didn't stream on Boxing Day. And also Happy New Year as well. Just like, let's hope that 2021 is less of a train wreck. But anyway, okay, so another thing, I was watching back some of the recorded streams, just like, I was trying to timestamp them and stuff. And I noticed that the quality of the recording was really abysmal. Like it looked terrible. Like it was impossible to read most of the stuff, particularly red text, which is like error messages and stuff. And this could just be an issue with YouTube's recording, but I suspect it's more an issue with how well I'm like with my laptop streaming. So I've ramped up the bit rate on the stream. Hopefully my internet will survive that, but I think it will cope. But hopefully this should be better. If there are just like issues with stream quality, then like feel free to put it in the chat. Oh, hello. Fin E, is that Finian? Or yeah. Okay, so pretty much what I've been doing this week. I'm probably not going to stream very long, but what I've been doing this week is setting up, like refactoring part of Sapling, which is the kind of how Sapling treats modal editing, right? Because in a normal text editor, keystrokes are just typing into the text. So I think I have Nano installed, and I type stuff, and my keys always go into the buffer, right? There's no way to have keystrokes do anything else. But how do we quit? How do we quit? Exit. Control X. Do I want to save the buffer? No. Right. So, but in Vim, that's different. If we just type keystrokes, they most of the time don't do anything. Like let's open an actual file. Yeah, this. Like so, keys move the cursor around or whatever. We can delete a line with DD, and so keys have different meanings depending on which state the editor's in. So Vim is in normal mode right now, and if I press I, it goes into insert mode, and now it behaves like Nano does. I can type keys, and DD will, instead of deleting the line, just insert into the buffer. And the way that Sapling had this implemented was a bit janky. Well, so Sapling doesn't have insert mode yet. So Sapling only has one mode. It has normal mode. And like that's fine for now, but it means awkward things like quitting Sapling was just typing Q, which is something that's very easy to do by accident, and it has no kind of prompt. Do you want to save? Just quits. Whereas in Vim you have you do ignoring ZZ for the time being. The way you quit is through Control Q. But Control is not part of normal mode. You press colon. You press colon and it goes into command mode, which is another mode. And keystrokes have a different meaning again here. And all of this is a bit tricky to implement, right? Because you kind of want a way of representing this that isn't just a giant if statement in the main loop with a load of, oh yeah, like if we're in normal mode, we add something to some invisible buffer that like gets checked for if it's a valid keystroke and whatever. If it's in command mode, we add it to the command buffer that's at the bottom of the screen. That's just a lot of, it's kind of inaccurate. And what NeoVim does. I have no idea if Vim does this, but NeoVim is, for those who don't know, it's a very heavily refactored fork of Vim. So some people got the source code and then just aggressively refactored everything so that it's now way easier to maintain. But it has exactly the same effect. Like, NeoVim behaves exactly like Vim. In fact, the version of Vim I'm using is in fact NeoVim. So there's NVim there. So I'm using NeoVim, but no one could tell the difference because it's just a refactoring job. And the way Sapling, the way NeoVim does this, if I just get a thing to draw on, 1000 by 800 pixels. Let me see. There we go. So if I just set the thing to be a decent size. So the way Sapling NeoVim does this is that it models the editor as a state machine. For those who don't know, a state machine is a thing where you have a start state. So it's a kind of imaginary machine, and it takes a load of inputs, and then on those inputs, it might change state or it might have an action, right? So for example, you could have an imaginary machine that starts in this state here, and then if it reads a 1, it goes over here, and if it reads a 0, it goes to a different state. If it reads a 0, or so if it receives a 0 specifically, if it receives a 0, it goes to this state and this state here. And so imagine that this is, and then we got implicitly that 0 and 1 keep in this state, and then 0 and 1 also keep in this state. And imagine that this is some kind of special state. And it's fairly easy to see that if you were to feed this state machine some stuff, it would reach this accepting state. The first character of the string, let's say it's only 1s and 0s, if that's a 0, it will go in this state and be stuck forever, because on seeing 0 and 1, it will just stay where it is. And then if it sees a 1 as the first character, it will stick here. Okay? And if this is some kind of special accepting state, then we could say that this is a state machine that will be in its accepting state if it reads a string that starts with a 0 and then has anything, because we don't care. This is the whole thing behind finite automaton. There's a whole field of cool stuff about it. This is how regular expressions are implemented, and loads of other interesting things. But the important thing for a text editor for a modal editor is that this is actually quite a nice way to represent a modal editor, because you could have some kind of state that we enter, and this is like normal mode. I'll call it NM, because my handwriting is so bad that writing anything more will just be indecipherable. And then we could just have, let's say we're in normal mode and we type colon. So here colon is an event. So typing colon, we would say that's the state machine receives the event that the user typed colon, right? And then on typing colon, it switches from normal mode into command mode, which is different. I'll call it CM. Okay, and then we need a way to return back to normal mode, and we either press enter, so enter, or let's call it return. You know what? GIMP has a text tool. And escape also should do that. But obviously the effect on the text editor will be slightly different in this case. If you press enter, then the command that you just typed gets executed. So in the case of, where are we? Where's Vim? Oh wait, for you guys it's just this. So as an example, if I switch back and go into Vim, nope, open something please, edit in normal mode, that'll do. So for example, if I type colon to go into edit mode and then colon quit, actually that's a bad example. What other interesting things are there? Oh yeah, so we can do something like set some parameter, or highlight, I don't know, what options are there? Blimey, there are a lot of things to highlight. Maybe highlight comments as blue, as red, right? And suddenly all of the comments are red. But the effect of pressing enter was that the state machine is now back in normal mode, but some action has taken place to this internal state of the text editor. If I had got most of the way through that, and then say R, and then pressed escape, then it would just clear everything and take me back into normal mode, where I can move the cursor around. So we kind of have an implicit another thing in, like, well, we need some kind of quit state, right? We have maybe some state, let's call it Q. And then in Sapling currently, if you were to just type Q in normal mode, then Sapling would move into this quitted state, right, which will just close the editor. And in the case of Vim, there'd be like you pressed. Actually, the colon is the state transition, so it would be like quit, and then enter. I'll just draw it like that. Will take you to the quitted state. And in Vim there's ZZ, which also quits straight out of normal mode. But I don't really use that. It's too easy to get a reflex for that and then accidentally quit everything. And so I was implementing this into Sapling so that there would be multiple different states that Sapling could move between, and then at some point we could implement commands, and that would be, that would be a heck of a lot easier than adding a whole load of craziness that would make it really hard to further implement things. So if I just go back here, I've got a fair amount through this, and the important thing is that it's really not obvious that anything has changed. If it weren't that the error messages were, well, like the log messages are now very weird. That's the only kind of change. Everything else works fine. The logging also works exactly the same way, I believe. Yeah, the logging is still fine, and so there's not much appears to have changed. But internally, there's now editor state, which has this kind of state trait that's kind of how you represent every state will implement this. And importantly, the important bit of this is the transition function, which is the kind of on Sapling receives some event, and then we need to make some potential movement across the tree, across the state graph, and so that this is what that function does. So we pass. So this function consumes the current state, and we have a key, which is currently the only way an event can happen. It got config, which is just some configuration. We need that because might need to look up key bindings and whatever. And then we have access to the tree as well. So this way we can implement things that, like deleting nodes would just be like a weird loop. They wouldn't change. They would go from normal mode to still in normal mode. But they do actually have a change. They delete a node. So this way we can implement that. And then we'd return a boxed state. And importantly, we could just return the thing we consumed, in which case nothing really happens. But we could create an entire new state and then return that, in which case the old state would get cleaned up at the end of that function and just destroyed. So this way we can implement the quit and quitting out of normal mode. So in editor normal mode, we now have another struct called state, which is normal mode state, and it has a default, which is just, you know, we needed a default because Sapling starts in normal mode, and we need to, like, where in normal mode do we start, right? And then we implement the state trait for this. And then the important thing is that suppose we just, so here's the interesting bit. Suppose we reach quit, right? So the user has typed some stuff, and the stuff happens to correspond to quitting. In this case, it's Q. Then we clear the keystroke buffer. I mean, that's not even necessary because Sapling's about to quit, but for the sake of we finished a command, we should clear the buffer of keys that we've recorded. Then instead of returning self as we would normally, so this is that we've passed the current state into the function. We don't want to return the current state because quitting is a state change. We instead return a new state, quit, which is the kind of special state that says Sapling needs to quit, or the user asked Sapling to quit. And then in the main loop, we now have a way of easily exiting so, and now we say, oh yeah, is the state we're in quit? And if the state is quit, then we exit the main loop. And this is a hell of a lot cleaner than what we had before, where we had to, like, there was kind of a thing that it would, like, user would type some keys, it would turn into a command, and then that would turn into an action, and then the action was fed into the DAG, which is where the trees are stored, and then the DAG would return a boolean along with some result that would say, oh, Sapling is supposed to quit. And that's really, like, that seemed really crazy to me, because it's not up to the DAG whether or not Sapling quits. It's up to this is just, like, above the level of the DAG. The DAG stores nodes, and there's an editor built around the DAG that actually provides usable stuff, and quitting should be part of that. So this feels a lot better. It's just that linking up the keystroke logger, it now takes a bit of effort, because because the code relied on the old system. And I have made a lot of changes since that. Which we got here. So this is the last commit on master, and then a few commits later, this is just so we moved the keystroke logger out of normal mode because I realized that if so the main loop can't see the type of which state we're in, right? Because of the way Rust handles dynamic dispatch, it erases the type. So there's not much point having keystroke logging as normal mode specific. We may as well make a way for any command to any mode to log things, like log keystrokes, right? So I moved it into its own module, keystroke log. I did some small cleanups. That's not important. I moved some stuff around, fiddled some more, and then this is the important thing that we represent. We added the state machine code, which is deceptively simple for how much power it gives us, right? And all it is a trait with some fairly complicated looking transition function, but it's just, oh, we have some input and we allow whatever the current state is to return a new state. And then normal mode, we take out all of the weird action stuff, because that's no longer necessary. And then instead we just have a state struct, which has the keystroke buffer that we had before, which is the buffer of keys that we've entered so far, as a string. And then we do the same checks here, that we parse the new keystroke. If our keystroke buffer is now a valid command, then we execute the command, right? So now we've got 3 states. Oh, we can open this in Vim. That will just be way Wait, easier to look at. Where are we? Editor, normal mode. Oh, we're right here. So if the result was an action, that is some kind of action that we can take on the DAG, that we can apply to the DAG, or like to the current tree, then we use it to execute the action. No, we just pass the action straight through. And otherwise we have, hold on, we don't need that. We don't need to implicitly return. If it's quit, then we return it. We force out of the transition function, say, oh yeah, we need to move all the way to quit. And then if it's incomplete, then we just return ourselves. We don't bother with doing anything. And then if the command was undefined, then we need to log that in the end, but at the moment we just keep going. We keep going out of the match, and then we clear the buffer because whatever the user typed into the buffer was undefined, and we should clear it and let them start again. And then lastly, we have a function that gives us, this is optional, all of the states can implement what the keystroke buffer is, and that makes sure that as you're typing, let's say we press I for insert, you can see in the corner that a little I has appeared to say, oh yeah, we've typed I, but I is not complete yet, so we await a second character, and in this case we could insert anything, let's insert an array, and then it disappears because there are no keystrokes waiting to happen anymore. So that's why that happens. And we still define what a keystroke could be because we need something to have a key binding for. And we still have actions, but we don't have an action for quit anymore because quit and undefined have both been removed, and they just don't, like, why we need to have them as actions is kind of dumb because all they do is get matched on and then panic or throw some obscure error that doesn't need to exist. So that's what we got right now. And I would, what's the time? Oh yeah, 25 minutes. It's apparently dinner time about now, but let's actually write some code. What I was doing was trying to get these messages correct, because at the moment, if we do something like insert an object, which is obviously one whole command in its own right and has one action overall, it currently just spits out two separate log entries, which is kind of like, why? So I thought that we could have the transition function of the state, no, editor state, instead of just returning the new state, which is this, we instead return the new state along with an optional thing to display, right? An optional log entry, right? So in the cases where I was pressed, we don't want to return anything here, right? Because pressing I, there's nothing to log yet, right? There's no point logging already because we need to know what the other thing to insert was before we can log. So we should wait till O and then log one single thing. So it would be an option, and then description is, we're supposed to return a string of the description, and something else, what does the log expect? Because the log, the keystroke logger, which is here, is storing a list of entries, and in order to create a new entry, we need to know two things, I think. Yeah, so we need to log an entry. In order to log the entry, we need to have a description, which is a string, and we need to know the category of what the thing was happened. And category is just an enum over all the possible things. It's like a move, it's part of the history, like modifying the history, like either undo, redo, it's an insert, it's replace, it's delete, it's quit, which now is its own thing, right? Because that is a category of actions, or it's undefined in some way. And so we need to know that, because that defines which color the log entries are. At the moment they're all blue, and that's because they're all claiming to be move commands. Otherwise they would be different colors. So we need to know that. So we need to know a string for the what the description was, and we need to know, or we also need to know a category for what that action was. So we may as well just return that. Where is it? Yeah, we need a bracket here, and this is a category. But the category, where's it defined? It's defined keystroke log category. Yeah, and it's complaining here that now this is not returning the right thing, self none, because expected bang. Oh yeah, there we go. So yeah, this is the nice thing about the state transition model as well, is that the transition function from quit, like pressing keys when the editors quit, is like, that has no meaning, right? So we should always just return whatever state we were given and then just return it back out. So that's like the transition function that says do nothing on anything. Like any keystroke you make, just do nothing. It's fine. Quitting should have no effect. Like once the editors quit, it should have no effect. And also we're just saying, oh yeah, if it's in state quit, then quitting is true. But now the compiler will complain. Query build. Oh, nice. Okay. Mismatch type. Oh yeah, that surely can't be the only place. Oh yeah, because we have more states to deal with. There's a weird intermediate state here, which is option string. We could probably do some like what is it? This is keystroke log category. What? Oh yeah, syntax. All right, okay, that's fixed this error. Pretty much we just changed the return type, and now we've got to fix a load of functions that used it. The important thing is that normal mode will now return something interesting. Let's copy that line. Editor normal mode. Okay. Yeah. Okay, so at this point, whenever we return, we either return no message, in the case of this. If the key was anything other than a character, then we return out, but do we want an action? Do we want some log message? Yes, we do need a log message because we've cleared the buffer. This is... Alright, so we're returning some. And it's invalid. What should we say? Something like... oh yeah, stopped writing command. Or yeah, so it's just invalid command. To owned. And this is category undefined. We should probably, in fact, just return an entry straight away, but for the time being, I'm going to do this. So instead of this, we quit sapling to owned. Wait, this should be some quit sapling to owned, and it's category quit. That should be happy now. What's it doing? Oh yeah, we need more brackets, I think. I would need to return self none. If the command is incomplete, then we don't want to log anything yet. What happens if we... okay, so currently that's that. If we return here, we need to know what the action was, because the action's description is what we want. So let's say description. So yeah, we're making this match return a description and a category as well. And we need to action dot description and action dot category. No, we don't want to return. We just want to return that out of here. And in the case of undefined, we return this is format undefined command s s, and its category undefined. Okay, and then here we return self. Yeah, because the only times we didn't want to log something is we would early return. It's in this case or this case. Otherwise, there is a description, and then this is actually, we could just say let log entry is this, because we're just going to return it as a pair self log entry. So is that nearly fixed everything? So it's fixed everything except that we now have some log entry to deal with. So editor. Yeah, so the issue is that our transition function now returns a pair, and we're packaging it into one thing. So let self.state, can we do this? We might not be able to. New state log entry is this, and self equals new state, and then log entry dot map. I want to run a function. No, let's just if let some entry. So yeah, so if log entry was something, so if there was an entry to log, then we should do this. We should log the entry into the keystroke. And then entry is description and category, and then we just pass description and category into there. But first we just always log, and we always add the keystroke. We say, oh yeah, a keystroke's been pressed, and then if a keystroke has been pressed and there was something to log, then we say log the entire thing and create a log message if required. Now let's just check. So can we just assign to self.state. Spicy. It looks like we can't. I didn't really think that would work. Ooh. Do like this action use after move. Where is this editor normal mode? Okay, Rust, why are you complaining? So action doesn't have a copies trait. That's interesting. So we just need to clone into here, I think is the easiest solution. Actually, this should be copy. Yeah, so there was nothing that copy is the Rust compiler way of saying, oh yeah, you could put this in a CPU register. Pretty much copying it is really, really cheap, is what it's trying to say. Does this build? Okay, it builds, that's a good sign. Does it actually work? Oh, it does! Insert true. And then if we replace with false. It's working. So I think now Sapling is back to exactly the state it was before all this happened. Which is that, well, you wouldn't be able to see any different. And also it's kind of like, this is kind of a bit pointless. If Sapling only has one mode, as it does currently, then why the heck would this be useful? But as it stands for the future, Sapling is a modal editor. That's what it's going to be. So it will have separate modes, which all do different things. So we want them to behave differently. What are the changes? Lots of changes. No, this one. Yeah, you know what? This is too long to go through on stream. So, and it's dinner time. So, I'm just gonna call it here, I think. Thank you all for coming and hanging out. It's been cool. Have a happy Christmas, everyone. Well, I hope you had a happy Christmas, and hope 2021 is a better year for you. So with that, I'm going to sign off. Bye-bye.